Hello, let's look at another percent yield question. This one will be slightly more difficult than the previous one we've done, and you'll see as we work through why that is. We'll start with a generic equation that combines some made-up compound W2, it's actually a diatomic molecule, reacting with two X's to form something called Y. Now, earlier we learned that percent yield is equal to the actual yield, which is what you get when you do the chemical reaction, divided by theoretical yield times 100%. For this question, we're being asked to produce, or we're told we need 500 grams of Y must be produced. Now, we're also given information that the percent yield for this particular chemical reaction is 80%. So we can think about it this way. If we make $10 an hour and we want to buy something that costs $100, we have to work more than 10 hours because oftentimes we might think 10 hours times $10 an hour is $100, but we forgot about paying taxes. Well, in chemistry, the taxes, I guess we could consider that's that the chemicals don't all react. So we don't get 100% of what we think we should get. We're only going to get 80%. So in this case, we want to produce 500 grams of Y. Now normally I write the information below the equation, but if I am using an actual yield, my method is going to suggest writing it above the reaction. Now, if we continue to look at this, that's the actual yield. We're going to have to find the theoretical yield, which is always what we calculate on the bottom. Now, because we know that we're only going to get 80%, we need to shoot for more than 500 grams. So we have to be above 500 grams. So let's calculate the exact amount for this using our equation we have right up here. So we're trying to find out how many atoms of W2 we want, and we'll also figure out the volume of X gas at STP. So I put 500 grams up here for my actual yield, and I'm looking for the theoretical yield down here, X. Now I'm told that it's an 80% yield, so I'm going to put my 80% right in here. Now normally I don't include the times 100%, so if I divide both sides by 100, I get the more traditional way, 0.8, that's 80% as a decimal, equals 500 grams over X. So now I need to solve this. So I'm going to multiply 0.8 times X, and I'll get my 0.8X equal 500 grams. To solve this, I will divide both sides by 0.8, and I will find out that X, that is my theoretical yield, is 625 grams of Y. What this means is I need to pretend or try to get 625 grams of Y, and I will end up with only 80% of this, which will give me the actual yield I need of 500 grams. So at this point, it becomes a regular stoichiometry problem. So I'm just going to set it up as we've done many times before. So what we're looking for is how many atoms of W are equal to 625 grams of Y. Because I have grams of Y, I must convert that into moles, and I'm going to pretend that's the element yttrium, so Y would have a molar mass of 89 grams per mole. And I will put that in down here for my conversion. 89 grams of Y is 1 mole of Y. Notice that my grams of Y up here and down here cancel, leaving me with moles of Y. Next, I need to go from moles of Y to moles of W2. So I'm going to use the coefficients. There's an understood 1 in front of the Y, and there's an understood 1 in front of the W2. So to make the units cancel, I'm going to write 1 mole of Y, 1 mole of W2. The moles of Y cancel. The next step is to convert from moles of W2 to molecules. Now, I know that 1 mole of anything, such as W2, equals 6.02 times 10 to the 23rd. Now, sometimes students will want to just be done, and they would have written, instead of 6.02 times 10 to the 23rd molecules, as I have, they would have written atoms and stopped. But this shows an ignorance of the difference between a molecule and an atom. You know that one molecule of W2 is composed of 2 atoms, so we need to show this last step. And this gives us a final answer of 8.45 times 10 to the 24th atoms of W. Let's now turn our attention to the next question, the one about what's the volume of gas that I would produce for this problem. So again, we'll set it up. What are we looking for? The volume of X equal to 625 grams of Y. Our first step, just as before, is to convert grams of yttrium into moles of yttrium. So 89 grams is 1 mole, so that grams cancel. My next step is to use the coefficients again. 1 mole of Y will be equal or be produced from 2 moles of X. So I make moles of Y on the bottom, 2 moles of X on the top. Moles of Y cancel. Finally, I recall that 1 mole of any substance at STP, if it's a gas, occupies 22.4 liters. So that moles of X cancel, and I'm left with my final answer, 315 liters of X. So this says I would need to start with these two quantities of material, and I would produce 500 grams of Y. You may be asking about, well, what happens to the rest of the material? Well, we'll have to look and talk about that again on something called, maybe the slide will be, how much excess reactant remains.